Imagine this, somewhere out there, beyond the reach of our telescopes, exists another version of you. You might be reading this very essay, just as intrigued by the mind-boggling concept of the multiverse as you are. Perhaps they are even wearing the same clothes. The idea that there could be countless versions of ourselves living out different lives in parallel universes has captivated scientists, philosophers, and science fiction writers for decades. But what if it's not just fiction? What if the multiverse is not just a product of our imaginations, but a scientific reality? Our journey into the mind-bending realm of the multiverse begins, a concept that challenges everything we think we know about reality. Imagine a cosmos so vast, so intricate, that it defies comprehension. This is where our story begins. It all started with the Big Bang, the monumental event that brought our universe into existence. But what exactly was the Big Bang? It wasn't an explosion in space, it was the rapid expansion of space itself, a moment when time, matter, and energy as we know them were born. Around 13.8 billion years ago, everything we see today, every star, every galaxy, every atom, was compressed into an unimaginably hot, dense state, smaller than a single atom. This tiny speck held the potential for everything that would ever exist. But this wasn't just a simple explosion, it was an expansion of space itself, a phenomenon known as cosmic inflation. In less than a trillionth of a second, the universe grew exponentially, stretching space to scales beyond imagination. According to inflationary cosmology, this rapid expansion set the stage for the formation of galaxies, stars, and planets. It was a moment of extraordinary transformation, where chaos gave way to structure, and the seeds of the cosmos were sown. But inflation may have done more than just shape our universe. It could have created regions of space that expanded differently, each with its own unique properties and physical laws. These regions might be so far removed from us that they are entirely separate realities. This leads us to the tantalizing idea of the multiverse, a collection of separate, self-contained universes, each a bubble in the vast cosmic expanse. Could it be that our universe is just one of countless others, each with its own story to tell? The possibilities are as infinite as the cosmos itself. Imagine these separate universes as bubbles, each with its own set of physical laws and constants. In some universes, gravity might be weaker, while in others, it could be so strong that stars collapse into black holes within seconds. The fundamental forces that govern our universe, the way particles interact, even the dimensions of space and time, could be wildly different in these bubble universes. Some might be hospitable to life, perhaps even harboring civilizations more advanced than our own. Others might be barren wastelands, governed by physics we can barely comprehend. Cosmologist Max Tegmark proposes a fascinating framework for understanding the multiverse, dividing it into 4 distinct levels. Each level represents a deeper and more abstract layer of reality, challenging our understanding of existence itself. Tegmark's work invites us to think beyond the confines of our observable universe and consider the vast possibilities that lie beyond. His framework is not just a theoretical exercise but a profound exploration of what reality could be, pushing the boundaries of physics, mathematics, and philosophy. Level 1 suggests an infinite expanse of space where every possible configuration of matter exists, meaning somewhere out there, there's an identical copy of our universe. This level is rooted in the idea that if space is truly infinite, then the arrangements of particles must eventually repeat, leading to the existence of parallel universes that are exact replicas of our own. Imagine a universe where every decision you've made has played out exactly the same way, down to the smallest detail. It's a humbling thought emphasizing the sheer scale and mystery of the cosmos. Level 2 delves into the concept of bubble universes, each with its own set of physical laws and constants, as we discussed earlier. These bubbles are thought to form as a result of cosmic inflation, a rapid expansion of space that occurred shortly after the Big Bang. Each bubble could be a universe unto itself, with unique properties that might be completely alien to us. This level raises profound questions about the nature of physical laws. Are they universal, or do they vary across different regions of the multiverse? Level 3 explores the many worlds interpretation of quantum mechanics, where every quantum measurement causes the universe to split, creating a multitude of parallel worlds. This interpretation suggests that every decision, every action, and every quantum event spawns a new branch of reality. It's a mind-bending concept that implies an infinite number of versions of ourselves, each living out different possibilities. While this idea may seem like science fiction, it is grounded in the mathematics of quantum mechanics, offering a radical perspective on the nature of choice and existence. Finally, Level 4 proposes a universe that encompasses all possible mathematical structures, essentially suggesting that mathematics is the ultimate reality. In this view, every conceivable mathematical framework corresponds to a physical reality, no matter how abstract or unfamiliar it may seem. This level challenges us to rethink the relationship between mathematics and the physical world, proposing that the universe itself is a mathematical object. Tegmark's levels of the multiverse not only expand our understanding of reality, but also inspire us to question the very foundations of existence. While the multiverse remains a largely theoretical concept, it has captured the imagination of scientists and philosophers alike. The idea suggests that our universe might be just one of countless others, each with its own unique laws of physics, dimensions, and even timelines. Though it may sound like science fiction, there have been some intriguing discoveries that hint at its existence, sparking debates and inspiring groundbreaking research. One such discovery lies in the cosmic microwave background radiation, often referred to as the faint afterglow of the Big Bang. This radiation, which permeates the universe, carries subtle temperature variations that scientists have meticulously mapped. These variations, though minute, hold a treasure trove of information about the early universe. They provide a snapshot of the cosmos just 380,000 years after its birth, offering clues about its origins and evolution. These temperature variations, known as anisotropies, are not random. Some researchers propose that they could be the result of interactions between our universe and other so-called bubble universes. Imagine vast cosmic bubbles floating in an infinite multiverse, occasionally colliding and leaving behind subtle imprints in the fabric of space-time. Such collisions, if they occurred, might explain some of the anomalies observed in the cosmic microwave background. Another fascinating aspect is the horizon problem, which refers to the surprisingly uniform distribution of matter and energy across the universe. This uniformity is difficult to explain under standard cosmological models. However, the theory of cosmic inflation, a period of rapid expansion in the universe's infancy, provides a compelling solution. Inflation not only addresses the horizon problem but also aligns with the idea of a multiverse, where inflation could give rise to countless other universes, each expanding and evolving in its own way. The echoes of creation and the possibility of cosmic collisions continue to challenge our understanding of reality, urging us to explore the unknown. Despite these tantalizing clues, it's important to note that definitive evidence for the multiverse remains elusive. The very nature of the multiverse, with its vast distances and potentially different physical laws, makes it incredibly challenging to observe directly. Scientists are actively searching for more concrete evidence, such as gravitational waves from colliding universes or anomalies in the cosmic microwave background radiation that could provide more definitive proof. The idea of traveling to other universes, perhaps even meeting our alternate selves, is a staple of science fiction. While the technology for such journeys remains firmly in the realm of speculation, the possibility is undeniably intriguing. If we could somehow bridge the gap between these parallel realities, what wonders might we find? Would we encounter civilizations vastly different from our own, or perhaps discover worlds where the laws of physics are twisted beyond recognition? The multiverse, with its promise of infinite possibilities and mind-boggling realities, continues to captivate our imaginations. It challenges our understanding of the universe and our place within it. While we may never know for certain whether other universes exist, the very act of exploring these ideas, of pushing the boundaries of our knowledge, is a testament to the boundless curiosity of the human spirit. As we continue to unravel the mysteries of the cosmos, the concept of the multiverse serves as a powerful reminder that our universe, vast as it is, may be just one of countless realities. It's a humbling thought, but also an exhilarating one, filled with the promise of endless discovery and the potential for unimaginable wonders. The multiverse, whether a scientific reality or a captivating thought experiment, reminds us that the universe is a place of infinite possibilities, where even the most seemingly outlandish ideas might hold a grain of truth.